So greenhouse effect is a very simple concept that we learned in primary school. So as a result, it's not a very difficult concept. So today I would like to just simply give you a gentle reminder to help you memorize the concept a little bit more easily. So let's start. So greenhouse effect, okay, according to your textbook, page 18, it can be summarized in a very simple diagram. But then I would like to give you a little bit more information, okay? So let's start with the sun. So all our energy, okay, originates from the sun. Without the sun, then basically the earth, it will be very, very cold. So the sun's temperature, the surface of the sun's temperature, which we call the photosphere, is higher than 5,000 degrees Celsius. Okay, so it's 5,000 degrees above. So as a result, the energy that it gives us out is very, very strong, very, very powerful. We have a name for this type of energy. So the energy that is extremely strong, extremely intense, we call it solar radiation. So and then in this type of solar radiation, since the power or the energy is extremely strong, so we have to give it a name. We call it shortwave radiation. So I think some of you may have learned something about it regarding the wavelength in physics lesson, right? So the shorter the wavelength, meaning that the stronger the energy. So this type of energy, so and then we have our atmosphere, okay, to protect these radiation. So since some of these radiation are so powerful, they are actually being absorbed at the outer part of the atmosphere, which we call the ozone layer. So but that's another story. But for the rest of the radiation, since the solar radiation is in general much stronger, so the radiation as a result can actually passes through the atmosphere. So the first important concept as a result is that since it's shortwave radiation, you have to remember shortwave radiation can passes through the atmosphere and reaches the ground. So and then as a result, what happened next? So after it reaches the ground, of course there are also something, okay, causing some of the radiation to escape, like what we have talked about, the concept of albedo. Albedo means the radiation will be reflected because the characteristics of the surface materials, like if it's snow cover, if it's covered by ice, then a lot of the radiation will actually be reflected back to space. But most of the radiation as a result will passes through the atmosphere and reaches the ground. So as a result, when this area, okay, or the surface of the earth receive the energy, so they will absorb it and then heats up. So the ground, or you can say the earth's surface, absorbs the radiation and heats up. So after that, so whenever an object is heated up, so according to thermodynamics, we will also release heat, right? So but then I'm not an expert about it. So but anyway, the concept is clear. So but how much can the earth, okay, heat up? Maybe on the surface it could reach up to 60 degrees Celsius, so on and so forth. But compared to the sun, with 5,000 degrees Celsius, is still very, very cold. So it's warm, but it's still very, very cold. So as a result, the energy that we release, or the earth release, is a much weaker form of energy. So it's in form of infrared. But we have an easier name for it for us to remember. So since the energy is much weaker, so the wavelength is much longer. So we call it the long wave radiation, okay, as a result is released from the ground to the atmosphere. So, and then the difference between long wave and short wave is that since long wave radiation is so much weaker, so we are not using the science concept to understand it, but we're using the layman concept. So long wave radiation is much weaker. As a result, they can be trapped. Okay, they can be trapped and stored in the atmosphere. So and then the effective things that traps the radiation is what we call the greenhouse gases. So as a result, you have to be very clear about it. Okay, so the greenhouse gas in the atmosphere, as a result, traps some of the some of the long wave radiation. Traps, or you can use the term absorbs this radiation. So, and then after it heats up, so the atmosphere is heats up, so the greenhouse gases trap the heat, some of this long wave radiation will go back, okay, to the surface of the ground, and then it keeps the earth warm. So, and then lastly, we can call it, we have a name for it, we call it counter radiation, or you can simply call re-radiate or re-radiation, okay, back to the surface. So this is what greenhouse effect, okay, how greenhouse effect works. So the concept is quite simple, and then let's add one more thing. So in the coming chapter that you are going to learn is global warming, okay, and then global warming leads to climate change, right? So as a result, what's wrong with global warming? It's quite simple. We only have to add a word in front of greenhouse effect. We call it the enhanced greenhouse effect or intensified greenhouse effect. So what's happened? So according to this equation, so of course, the long wave radiation is released over here in step 3 over here, some of the long wave radiation, and then since in atmosphere we don't really have that much greenhouse gases, so there are actually some of the radiation that will go back to space. Okay, they are not being trapped by the greenhouse gas. So what's the enhanced greenhouse effect is that we are having more and more greenhouse gas in the atmosphere. So what's that mean? Meaning that more greenhouse gas in the atmosphere, as a result, more long wave radiation will be trapped or absorbed. As a result, there will be more re-radiation back to the surface. Now since that, then the equation is not balanced, so more and more heat accumulates near the surface, it will increase the temperature even more. Okay, so that's what we call the enhanced greenhouse effect. So two misconceptions that is very common. First of all, be very careful, very careful. The solar radiation, okay, cannot be absorbed by the greenhouse gas. So I repeat, the solar radiation or the short wave radiation over here, okay, cannot be absorbed by the greenhouse gas. If you write that, your answer will be incorrect. Okay. Number 2, you have to be very careful that the ground surface will release long wave radiation, because even though it's heated up, it's still much cooler than the sun. So it's a much weaker form of energy called the long wave radiation. And then lastly, the greenhouse gas can effectively absorb the long wave radiation. Now, so that's something that you have to be very careful about, and don't get confused with greenhouse effect and global warming.